Hello everybody. Here we have a homemade transformer winding machine. And I'll just put it on for you. First thing I had to do, that's the LCD screen, is it's only just run at 5 volts. Just to check the power circuit. There's no software or anything there, it's blank. So yeah, got the 5 volt circuit here. And just running on the power supply. So I set the current to only draw 100 milliamps or 100 microns. Look, 0.000. At the moment it's drawing 21 microns. No, 21 milliamps in this case. And I've got it there, I've got 19 volts. And it's powering the regulator to 5 volts. So the LCD screen there, it's taking 21 milliamps. So when you build something and you test it bit by bit, you actually get to know exactly what the components hooked up, how much current draw, you can test and all that stuff. And that's the microchip that installs here. So I'll switch the power off. And this is a circuit board that I had for ages. It's just only like for testing, like to practice with your microchip. It comes with some sort of kit that I got. And I modified it, I'm just going to use it for this, but I had to do a lot of modifications and run all the wires. And this module here, look how small it is. It's the stepper motor controller. So that's going to be, it plugs into the sockets here, into there. And this one here is going to control the winder motor. Look, I changed the heatsink on it. And this small controller here is more powerful than this. And now I found I could have got something this small that instead of this big thing here. Anyway, I'm just going to use this now what I have. Okay. Here we have the whole controller circuit, which is still not finished. I mean, actually the board and all the components are all installed. And this is another module to run the pickup of the, what do you call it, the counter system. So I had to use an op-amp and a inverter just to get a good real square wave signal. So that's built and it plugs in to the main board there. So everything is made to be taken apart and everything's going to fit in this box, and it's a one unit which got the whole control, everything in one box. So it was a bit of a challenge to do. So I used a computer lead there. I think it's a how many pins? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 looks like. 15 pin. And I managed to have that. That was of a PC. And managed to fit it in there. And I glued that part there. Still comes apart. Rerouted some of the wires, changed them to suit my circuit. So everything is made that you can use this controller, the box, that will all fit in there, and you can remove it just by unplugging the plug. And also still made that board goes there, that you can work on the board or repair it. So everything is made to come apart, and that was the challenge, because it would have been easier just to just solder everything, and then, but what happens when you have a problem or something goes wrong? Everything's going to be protected anyway. But anyway, that's the motor that controls the brushed DC motor. So like even the heatsink, that's not the original heatsink, so it's much bigger. So everything's going to plug in and screw in, whatever, and then you just put the case on top here. It will be all closed up, and it's got all the controls here, and all unplugs there. So that's all. There's not going to be any holes or any more wires going into it, because it's all done through this plug here. Now that was a bit of a challenge to fit everything in this small box here. The wires are not in the way to be able to take the boards off and all that. So everything's like in a modulated format, like that thing plugs into there. Still haven't so the controller there, still haven't tested anything, or it's not finished yet. But the winding machine, the transformer winding machine, which I've built from a printer, an old printer, I took the carriage, modified the whole gears here with the system of the motors to make it suit to what I wanted. It's an old drill that I kept, and that's the brushed motor, which is going to be forward, reverse, and pulse width modulation to control the speed. And I've put a sensor here to pick up how many turns I'm doing, and this is of an old Bosch, which I cut and modified and put bearings. So I'm using like a wood frame that I made. And then here we've got a clutch system, parts from video recorders, from the old video recorders. So you can adjust the spring tension here on the clutch to create a tension for the spool of the wire. And that's just a handle that once it's running, I mean, before you run the system, you take that off. That's if you want to wind back the cable, the copper wire back. And so this carriage here is going to move along there, and to guide the wire. So these are all parts from old video recorders. Haven't, how I said, tested anything yet. Well, some things is tested, but not finished yet. And the controller is going to be there. That box, everything is going to control the whole thing. So the only thing that I have to mount is the power supply here. Gonna mount the power supply there, and just a voltage DC to DC converter from 20 volts to 12 volts, and it's going to feed the whole controller box, which is going to control 2 motors. And the LCD screen, you can program to tell it how much movement the carriage is going to move per turn. And that's the plan. So after that point, I'll show on the next when I have it all installed. So anyway, this is the transformer machine that I've built, and it's I used a printer carriage. I tried to use the stuff that I had lying around, and I had to change the motor. Of course, it's a Canon printer. It's an old printer anyway. They had a servo motor controlling here the belt, which moves the carriage. So I've changed that because I couldn't really run that same motor. I don't have enough sophistication with the circuits and to do that. So I use the stepper motor. So I use the stepper motor part of one of the other stepper motors of the printer, but I had to modify this section here. So I had to fit a different gear. So it's a bit of a mix and match to get a higher ratio. And as you can see there, that's not how the original printer was. So this is from another part of the printer, and could be I think this gears was from a different printer again. So this changes the ratio here from 1 to 3.2. So one turn on the motor does about so what am I saying? 3.2 turns on the motor does one turn on the big wheel here. So I had to glue the gear that drove the belt onto this other gear. So I had to cut part of it and then epoxy it with actually JB Weld, and that worked fine. And then I had to get a circuit that ran the stepper motor, which was, it's a motor controller that does a 16, divides each step into 16 times to gives me again more resolution, because this is the problem using this system without a servo system. So the servo system can move the motor much finer than a stepper motor. But the other way that I could have done it is to use like a worm gear carriage, like how they use on a lathe. But you know, I try to use what I had. So I've built from wooden frame, as you can see. This is a one of those eBay specials, DC to DC voltage converter. So the input is there you go, 20 volts. So it's a printer, sorry, it's a laptop power supply that I fitted there, and which I'm running the 20 volts. It's actually running the stepper motor, and then 11 volts, 10.9 there, step down to run the brushed motor, which is of a drill, one of those electric battery operated drills anyway. Something that I had lying around as well. So it was broken one, so as you can see I used part of it. So I built this frame here and I made it fit in there. Okay, and on this section here is just to hold the rod, and also it's a counter. So I've made my own counter. This sensor I've made it could be off a printer as well, but it's using IR, just an LED and infrared receiver. So it's actually like a transistor type of receiver. So I just fitted in this bolt here, and it's all fitted in there. So actually I'll just show you this. So I'll undo this, okay, just for the sake. Of course I already set up I'll put that down there. So if I remove this was of a Bosch electric drill, okay. And I've cut the shaft and machined it down here to fit a different bearing. As you can see in there, this phone got a habit of shutting off as soon as you touch the screen. Bloody Samsung rubbish, mate. Anyway, and you can see there, it's shining the LED. And what I got here, I put a bit of tape there that I glued. And I've put liquid paper as a reflector to reflect back to the receiver. Okay, so that's how it's sensing the counts. So that fits in there. It's got a bearing at the back there. Okay. So we'll fit this back. Okay. So here's where the spool wire goes. And this is just a test here that I'm going to do. And this part is a clutch system that I made to create some tension on the wire. And it's parts from a video recorder, and I made this bracket here, and to tension the spring you just turn this to put different pressure. And it's got a clutch felt there. This is the controller that I've made. So we got left for the carriage, that goes right, so manual move the carriage, and you can adjust the speed. By the pot. And this also pot adjusts the speed while it's running to speed up and slow down the motor here. And this is the start and stop button. And as you can see there, it's going to measure the layers, the turns, and the distance that it travels. And this is the wire gauge. So at the moment, right, I've got it set at this size for each step, 0.144, which I'm still testing because this cable size is around 0.1. I measured it, 0.145, I think. Anyway, that's the closest that I can get for the ratio that I have on the carriage movement. So anyway, I'll put it on for you first. Okay, so when we go into the settings, press this button here, input the value. So you can change the how many turns. At the moment I've set to 1200 turns. So this is to change. Okay. Distance. So the distance is from that point to that point. So I've set it to 23.2 millimeters. Do you want it to stop on each layer? Yes, in this case, because I'm going to wind each layer and then put tape, wind another layer and put tape again, and so on. So I want it to stop on each layer. Direction when it starts, it's going to go from left to right at the start. Wire gauge, okay. So this is the only ratio that I could change, right? I can change there, the different sizes. Okay. So that's each step, 0.0103. That's the smallest step I can move with this system here on the motor, right? If I was using a screw type carriage, then I would have been able to have more resolution, but this is going to have to do for now. So I only pretty much made this machine just to wind one transformer for this valve radio. We'll go up. I think that's the size that I'm going to use. Okay, and press that. will step out, zeros all the counters. And I will, oh yeah, and here I've got an external counter which I had lying around for many years, which is just there for safety. If the power goes out, this is still going to keep the number of turns because it's powered with its own battery. Of course, I could have made the circuit here to have backup, battery backup, but at this stage I didn't do that. So, but it's good to have two different counters, just a reference. Make sure that everything's working, double checked when it's working. So I'll show you, I'll stop the video and then I'll restart it again when I set up the wire here again. So I'll be able to do a test run. So this former is another one that I've made. It's cardboard. I put this heat temperature tape on it. At the moment I can't remember what they call this tape, capstan, or I can't remember right now. And it's got an LED here just to tell what do you call it? It tells me when it does a count. There you go. Yeah. Each count is when the sensor picks up, it lights up the LED, so it's another reference. And also, I've made it where when I zero the counters, it says 5 turns there, 5 turns there. I zero, so I'll press the button and it zeroes both counters. But when the power goes off and comes back on, this keeps the last reading. So in here I've made a small pulley sort of guide which slides over the shaft here. It's so when you have a different spool here, it tries to move along, sort of guides the wire. And this has got a tensioner here just to keep the wire a bit tight. And of course it's got the clutch tension here. And so alright, stop the video and I'll show you when I set up here, and we'll see how it's going to wind the wire. Okay, so I've set up the wire here again. That's the start of it, and it's going to move 23.3 distance from there to that point and then stops. So the machine actually, even if you have it set at full speed, okay, on the pot here, it will start slowly and then speeds up, and then when it comes to the end, just before the end, it's going to slow down. So that's how I set in the program to do that. Okay, so here we go. We'll start it. It's winding. The distance moving there and the turns. Okay, so let's see what it did. It moved 23.2, okay, and it done 161 turns. So, and that says 161, the same as that. And let's see what it did here. Very good. It actually done a good job. perfect. Actually, I'm surprised. So that's the first time I've ran the machine. I know I've done a lot of settings and before, and it done a perfect. I don't know if it can focus this, but perfect. There it is. You can see that. So I probably should have been slightly a bit more this way when I start. Oops, when I started. But okay, so I think it's going to work okay. So that's the first layer. Okay, and of course here it shows us it done one layer, the first layer. And now of course when I press the button again, it will wound from that point to that way. It will go left. But I need to put the tape on the transformer first. Okay, I'll pause this. Alright, I had to do some adjustments. I've realized that it's done the first layer, but it actually I didn't set the distance correct, because it actually counted 161, I think it was, wasn't it, turns. And actually I'll check that. Okay, so yeah, I watched the video again. It counted 161. So I needed to count 150. So I had to adjust. If I go into the setting here again, I had to readjust the settings, the distance, to 21.63 millimeters. So if you divide that 21.63 by the wire gauge, 0.1442, you should get about 150 turns. So now I took the turns off. I took turns off. Can you see now it's more balanced? I had 10 turns extra. And so I put tape on there, by the way, on top of this layer. I put tape, and because the tape is wide as the former size here, and I'm not winding to the whole way, I had to do a small slot here, cut in the tape, to be able to get the wire out and then get ready for the next layer. So in the settings here, because I've changed them, I changed the distance, and I'm going to restart the machine. Now I'm going to go from right to left. It's going to start from the beginning. So I'll escape. Okay. And let's see. Watch the next layer. So let's hope for the best. We're going to start. 1, 2, go. There's the second layer. There you go. Second layer. And looks like it done another perfect job. Very good. So now, there you go. It's actually counted 151. Still an extra turn. Because it moved a bit more. That's because you see it jumps by this figure here. You'll find that that's why I've got an extra. turn there. So there you go. You can see it hasn't crossed the wires. The turns, so it's very smooth. So that's the second layer. This phone, stupid phone, mate. All right, so anyway, that's the demonstration there, and might have to work out some fine adjustments on the distance, but overall I think it's going to work just fine. And so this, of course, this carriage used to have the printer cartridge here. So what I did, I had to of course not use that, but these are parts from video recorders, and made some bushes and spaces, and to create this wheel here, which is fine for this cable. So that, you know, this is the guide, this is the tensioner to keep the wire tensioned with a spring. So all this I glued and made it fit onto this carriage here. Of course, remember, I'm using parts that I already have. I mean, if I was doing this all the time, I would change the system and put a screw type of carriage, and of course everything will be different here. But because I used what I had, it's just to show you that even you can still do things using things that you have. So the main, not secret, but the main part was the steps. This is what determines whether it's going to work or not. You need your steps to be accurate. So each turn, it picks up, okay? It will do a step, and the step should be the size of your wire gauge. And the tension, of course, is what's going to tension your wire, and that's done by the tensioner on there. And make sure you have a spring here to keep the wire tensioned. While this thing is turning, it can create the wire to be goes off tension. So that's the idea of the spring. But yeah, so it's important as well, it starts off slow, so you don't jerk the wire and might cut it, being fine. And then the programming, and later on some other video I'll show you how I made the program for this to run control the brushed motor and the stepper motor and the counter. And what else I can show? And what I showed here, sorry, I've built the whole control is built in this box. So the only thing external is the actual power supply side, which the step down, which on the step down also I had to make. This I've got one of those Chinese eBay job, but I did have to put a heatsink on the board for this chip, because this motor draws about 2.5 to 3 amps. And this chip will get very hot. The way I'm running it, I'm stopping on each layer, it's okay. But let's say you were running it non-stop, it will get warm, and without the heatsink it will get hot. This heatsink here is part of the DC motor controller for this motor there. And that's a heatsink that I added, I changed from the original. When I show you on the other video, I'll show you that. Here I have the transformer winding machine that I built to wind a small transformer. I made a video about that. And what I intend to do is to do a small modification on it. I've set up the controller here to control the motor, of course, the DC motor here, brushed one. To when it starts, I can set the level of speed, but from start, the start button, to normal speed operation, it actually speeds up gradually, so it doesn't pull on the wire too much, doesn't start abruptly, even if you forgot the speed to full. And I'll show you here. Okay. Can you see how it sped up slowly, gradually, up to the full? So the only problem with this is fine for the real fine wire, but when you come to 0.9 wire, it's quite a thick cable, or over 1 mil. If you start it at the start, because I've made it gradually builds up the speed by pulse modulation to the motor, right? You'll find that the motor hasn't got enough torque to start, and you have to help it. See, if I stop it to start. And part of that problem is because the controller here is a transistorized system to the motor, right? So when you apply pulse width modulation and you have load on the motor, it's just not enough torque. When this transistor switches, you got high resistance build up. So I intend to replace it with this module here, which is a MOSFET, not a transistor, to switch the motor current to the motor. So the MOSFETs have very low resistance, unlike transistors. So into the milliohms. So it should, with this unit, get more torque onto the motor. So that's what I intend to do, is to replace this with that. So we'll see how we go with that. Okay, so took the screws off here. I built this just over a year ago, and I fitted everything in here, so in a small box. So I got the LCD display there, the pot, the switches, and that's the motor driver, which is just a chip there with the transistors built in it. So it does reverse the motor polarity as well. Yeah, so I'm gonna have to try to I've cut, of course, the plastic here to suit this, so I'm gonna have to change all that, but yeah. So I'll remove this with 2 screws there, and start by doing that. Right, so what I got here, if I remember right, this is the motor outputs, and this is the power in to power up the board and the motor actually, and this is the controller. So this goes to the microcontroller and gives out pulse modulation and some inputs here regarding polarity of the output. I'll have to look back at the circuit diagram to tell you exactly, but that's the control wires there, just 3 wires. Of course, I modified this board as well. Originally, it had another connector somewhere there, and I had to cut that off. And just that's right. I bridged because this is a dual actually IC, a dual output, so it's made to control 2 motors actually, separate. But I bridged the two together to get to share the current between the 2 channels. Otherwise, we'll get too hot. That's the other problem too. At low RPM and with torque, it will get hot. That's why actually that's not the original heatsink. So the original heatsink that came with this was much smaller. This is actually a heatsink of a Pentium 2 CPU heatsink, which I cut from the, there's a big heatsink. I've cut a little bit of it to use for this, which worked quite well. So how I said, this works fine, except for the real thick wire at startup. But I'll just try to improve it. So you got to disconnect the wires and see how I'm going to fit this unit. Okay, here I'm looking at the controller for the motor controller. The BTS 7960, and that's a picture of the original PDF file of the BTS 7960 chip, which contains a high side and a low side MOSFET. Okay, one's a PNP, the other one's an NPN. And the way this works is when the high side is on, you will need the low side on the other side on. And these will be the opposite across. So the current, let's say if you got the high side on there, then the low side has to be on. So the positive goes to the negative, and these will be off. And when you change polarity, you got the you will have the low side on here and the high side on here. So the current will flow from the positive to the negative, and the motor goes the other way. So that's that part. And then if you look at the truth table of the chip, it's got 2 inputs. One says in, the other one in H. And the way in normal operation here, it's saying when you have a 1 on, when it's high on the H, and the in is low, the low side MOSFET is on. Okay, and when you have again a 1 on the H, and you have a high on the in, then the high side MOSFET is on and the low side MOSFET is off. Okay, so and when you have nothing low on the H, the high side and the low side is off, it's saying. And X, it's saying it could be 1 and a 0. So here, X equals 0 or 1. Okay? So the way to run it is to have the H is always high. Okay? And when you have a low, the low side is on, and when you have a high on the in, the high side is on. So they can't, if you put pulse width modulation here, you're constantly swapping these two. They're switching. So when the pulse width mode is on the off side, you got the low side of the MOSFET on and the high side is off. And vice versa, when the pulse width goes high, then the high side is on, and so you're constantly locking the motor. You're constantly bridging the motor, shorting the motor on the off side. And this is not a circuit diagram that I found on the net, which was very hard to find. This is showing how this basically here, the Hansen technology, which it's not really theirs anyway, it's an Infineon chip. This could be, of course, a copied chip from China. And the way they show you here, they don't actually show you the buffer chip, which is a SN74. They're actually the driver. They're using this buffer here, which is SN74AHC244, and so that's the chip they're using, and this is the input header on the motor controller board. And basically it's just a buffer, buffering the inputs. So, and the way they tell you to run it here is even the wiring diagram. So 1 and 2 you'll have pulse width modulation, and 3 and 4 are always high. Okay, so 3 and 4 corresponds to in H. Okay, so it corresponds to, where is it here? This input here. Okay, they're in H. So that's always have 5 volts on it. Or it's high, I should say. And then, this of course referring to the Arduino software that these people has made here, which I don't use this, I use actually Big Basic Pro. So where is, so yeah, pulse width modulation on pin 1 and 2, and 3 and 4. Okay, they're saying it, called it enable, which is the one with the H in H, is always high. So they put 5 volts there. This is for current sensing, unconnected. And then you need the supply, 7 and 8, 5 volts. And that would be to run the buffer chip as well. So when the motor is running, you are constantly So looking at the circuit here, when the pulse width modulation is on the offside, you're actually shorting out the motor itself, right? Not the power. You're actually grounding that point to ground. So that MOSFET is on and this MOSFET is on. And so that's what you are doing. Which this is a good thing because you have braking constantly. So as soon as you remove the pulse width modulation on the inside pin, the motor would lock and stop straight away, okay? And also, when it's running on pulse width modulation, that means that the motor is not free running, so the magnetic field is controlled, you know, each step of the pulse width mode. The current continues along the magnetic field around where the motor sort of, it's on the offside, it sort of stopped at that point, and then it's going to continue back. So the motor is very controlled constantly with the pulse width mode. So I'm assuming, I haven't used servo motors, but I'm assuming that's how they would work as well. The servo motor, to have control on the motor, to step a motor with servo, right, you would need to lock the motor, because if you leave it free spinning, it's just already moved too much on you. So on the offside, on the pulse modulation, the motor gets shorted. So you're locking it, you're stopping it in the off mode, not letting it run, because each magnetic field, it could be in between polarities of the poles of the windings around the magnetic field poles on the motor, right? So before I connected it here in the system, it's not here, I'm doing a trial, and so what I did is pin 3 and 4, which is these blue wires, they're connected to 5 volts, they're together, okay? And 1 and 2 is one side of the, because it's got two sets of MOSFETs, right? And each MOSFET has got a high and low. So this MOSFET have a high and low, and this MOSFET has a high and low. So, which is creating the bridge for the motor, right? Now, 1 and 2, one will be one MOSFET, and pin 2 will be the in of the other MOSFET, right? So that is connected. I'm going to connect it to the pulse width mode, and at the moment I'm just using a generator here to create the pulse width mode, okay? And I've got an oscilloscope running there. So as soon as I connect that to the pulse width mode, okay, the motor should be running, but let's see here. Okay, I got the wire disconnected. It's missing the 5 volts. Okay, and that's showing on the scope. Okay, so I'm going to speed up the okay. So I've got it running at 1 Hertz, the pulse width modulation frequency. 1 kilohertz. Now that's running on low, okay, and just holding the motor, it's still turning me. Look, it's very strong, and that's when I'm putting load on it, a lot of load with my hands. So yes, it does work better with the MOSFET than the other chip, than this one, which is transistorized. And changing the duty on the modulation. So the motor, right, in this section here, and the off section, is actually shorting out the actual motor itself. So it's locking the motor, right? And then when it goes high, it unlocks it, removes one side, and it works, right? Now, just to prove the braking on it, so I'm going to run it at fully on. Now when I remove the in pin, you watch the motor lock straight away. You see, constant lock, and I can feel very tight because I'm shorting the motor. So yeah, this it should work very much better. And what I need to change here is, originally with this system, I had one pulse width motor output, and then so this was the control part of it. It's 3 wires. So one side was one pulse width mode, and the other 2 wires were for reversing the polarity. So one's enabled, one's high, the other one's low. And if you opposite those, the high becomes a low, and the one that was low becomes a high, then it changed polarities. Okay, so I'm gonna have to wire it different. So now I'm gonna have one enable, which enables the 2 set of MOSFETs all the time, and I need 2 pulse width modulation coming from the microcontroller. If I want to go left and right with the motor, if I wanted to go clockwise and then anti-clockwise, if I only gonna run it only one side, then I only need 1 pulse width modulation. In reality, that's all really I'm gonna be running this. You would only need to swap the motor going the other way if you're gonna unwind the motor, the transformer that you're winding, and you wanna somehow to go back on the spool. So yeah, so I'm gonna have to change the circuitry here, and I'm not sure if I'm gonna be installing that there or outside, because this is much bigger. So yeah, so anyway, it's already a big improvement, this board, this BTS 7960. It's yeah, it's a very good design, and no heat at all, because the resistance when it's on is in the milliohms. Yeah. Okay, what I ended up doing with the transformer winding machine, I actually modified it. Not only that, I've changed the controller that controlled the motor, the winding motor, which is that BTS unit that I explained. I actually didn't fit it in here because it wouldn't really fit properly there. So where I had the cut, I blocked it off here with a piece of aluminium, and I ended up making a bracket, aluminium and posts there, brass post, and I screwed it there. But I also, as you have noticed probably, is I have rebuilt the whole unit, and I moved things around. So of course here I used a new base, and before I had the motor in the middle and I had the carriage in the front, And the reason why I've changed this because it's much better to have the transformer. I mean, I did have a look at some transformer winding machines, and I did see that in most cases they have this part on the front and the carriage will be behind. And from what I can understand, which I experienced this myself when I wound a transformer before with this, when I had the carriage in the front, is I had to put my hand over, so where the carriage is now, that's where the transformer was, to put the tape, and so it was uncomfortable to work. So it's much comfortable here to have nothing in the front. And this is what I'm working on, so I can easily put my hand around it, the tape, whatever. And there's nothing there. I don't have to put my hand over. So I thought, since I was going to modify, well, update the motor controller, I done the whole thing and I've made it a bit better. Of course, this carriage is from a printer, and to make this machine better is to have a different system here with a winding screw, not a belt system. I actually had to modify that section there because this I'm using a different motor here. It's not a direct drive, so I've got some gears and then I'm using a stepper motor. So anyway, I also made a front sticker for it, so it's all complete now. So I have if it can focus, I don't understand these phones, how they don't focus, but anyway, yeah, well, now it's focusing because I restarted the camera. Google, Android, full of bugs. Anyway, so I've made a new, well, I've put a same box and I just put a front with what these buttons are. Cursor controls the carriage left and right, and stop and start. And I've got the speed for the motor. And going into changing the parameters here. So you press that, wire gauge, turns, how many turns you want, distance to travel from start to end. Do you run each layer or would you stop on each layer? In this type of transformer that I'm going to wind, I have to stop each layer so I can put tape, insulation, and then continue on. So I would change it to stop each layer. Direction for the carriage. Winder forward or reverse. Do you want it to slow down at the margin or full run at margin? So that will slow down just before the margin, the end of the margin here on the sides. Back to wire gauge, and you change the values, so you move the cursor, okay, and when you're done you escape, and to zero the system you hold it down. Okay, it also zeroes the external counter that I've got there. So yeah, so I've mounted everything here. It's sort of much neater than before. So speed controller, the 19 volts to 12 volts. It's a laptop power supply. Okay, so this is the input voltage of it. And that's the output out of the DC to DC converter. And I think I did explain this before. That's a brake tension. That's not a brake, it's just a tension on the spool. Okay, that's off a video recorder. When I used to fix video, so I kept some of the parts. So you loosen it by unlocking this, and you move it back, and you remove the tension on the spring. This just in case you want to wind back. And also, if I hold here what I put, the unwind wire, of course you only have to do this, you need to do this by hand. You hold this for 3 seconds. I call it emergency reverse, and what it does is when you start winding back by hand, you unloosen this, so this can spin freely, and the counter counts backwards, so it goes in reverse to whatever you got up to. And then when you fix the problem, if you had a problem and you had to go back, then you hold that again and it goes back to normal, and it continues on from wherever you were. I've put a sticker here as well, reverse and forward. I also put micro switches here, which I didn't have before, just in case you're mucking around with it and you keep going with the carriage, not to break anything. So it stops, and then you can't go any more left, but it will go right. So I've got 2 switches, same thing there, so they're limit switches. Okay. And if you're running, okay, and you hit this, it will stop. Of course, it's not really going to hit, it's only there. I'm only going to be traveling from there to there. So some people, of course, have made these switches to be as a to stop the carriage running for how long the distance of the former is, and then it can make it reverse. But in my case, it's done by the software. So I put the length here, and we'll stop at the length that it travels. I'm not really going to do it with the switches, so I only put the switches there as a safety. Somebody mucking around with it, or you had it set, you had this the start there, and then you started it, okay, and okay, let's say I'll do it again. I'll zero it here. Let's say if you got to put that in the middle, you'll start it, and it just stopped there if it's a safety because it hit the limit, and then you would realize you shouldn't have been over that side. So that's basically it. So oh yeah, I also did make new rollers here. I made this new roller here, not out of nylon, on the lathe, and that actually slides. So before I only had one, I had this one roller, and now I've got 2. So the wire is going to go underneath there, and from the spool underneath, and then it comes up onto there, around there, and back to the transformer. So when I start winding, I will video that as well. So yeah, that's it for now. And here I'm going to demonstrate the transformer winding machine, and I'm just going to show the other features of it. So this is where we put the wire. This is of course not the best. This is not the best thing here. Normally I don't use these. the spool. Okay, I've got a taper there to fit different sizes, and I've put a fly nut here. Okay. Okay. So we lock this. Okay. Now what I did here on this tool, as you can see, I machined this thread. That's one side, and that's the other side. Okay. So I come up with this idea to be able to remove this from this section here. So that's the way I've done it. And let me pause it to show you that part. So now I've got it at the back here, so you'll be able to see. And this unit, you'll be able to take off from here, so you can be able to put the spool holder of the wire. And so it's like a quick release. This will fit into this section. And here we'll lift this, push this lever, and we will lock it into there, and that will come down. So now it's there. Okay, so just show you that again. That fits into that. Okay, and this section fits into that. So here we'll lift up this. Okay, it's a bit hard to do it with one hand, but I will. Okay, so that I pushed it in, that comes off. Okay, so you can see that locks into there. Here's the bearing there, the top lever, spring loaded. There's a spring there, and where are we? The inside of that part. Okay, that will fit in there. This section here, we'll have to push this out. Push that out, and now it's a bit hard to do it with one hand. Hang on a minute. That's because I'm holding the phone and at the same time doing this. Okay. Now we'll push this until it locks with it. If I can see what I'm doing. And that's in there. So it's locked. And down here, I've done that as a key, and we got, that's the same thing there. That will fit into there. One way until it engages. There it is. So I can, when I want to rewind back, I'll rewind backwards, and this is the clutch system to create a tension on the wire. So there's a clutch in here, and depending on how much phi you'll have that in, it will create the tension. So that's that part. Now this part on the carriage now, this is spring loaded. Okay, so it's a roller and a roller there, and there's a bearing here as well with a roller, and this part adjusts. So I've got a fly nut here. Okay, now this extension here, I got the idea of another transformer winding machine. and I sort of made my own similar. So now I can adjust this. Okay. Okay, I can adjust how close you want to be next to the transformer. So before I never had that adjustment, I had just a fixed roller. So I've made it more precise by having this. And you tighten the nut here. Okay, and that will be locked. Okay, and this is to keep the tension of the wire. Okay, spring loaded. So let's see. So there's the wire there. Okay, it will have to go underneath the first roller here. So and once you got it over there, then we'll feed that on top of this roller and underneath this one, so it's like that. So now I got tension. Okay, there it is. Okay, so the spool goes underneath this, up over this first roller, second roller with a spring tension on it, and now we go over the last one. Okay, and let me wrap some tape around this. Okay, and we'll lock the shaft. Okay, and it's pretty much ready to wind. Okay, so that's how to load the wire. So that's the improvement, and I've got the light here now, LED light, to be able to shine, and it's adjustable. Okay, I got this from a lamp, old lamp that I didn't use, and I fitted it onto there. And the carriage I bought, okay, and I've made all these top bits here. I manufactured these myself, and the stepper motor is a different stepper motor now. Okay, and so now I will show you how to winding the wire onto the former here. Okay, so just to start, I'm going to measure the wire, just double check the wire size again. Now I got about 134 with the machine on. That's what it said at, 134. So we're going to go into setup. So this is the resolution that I have. So it's 1343 at the moment. I can go to the third digital number. Okay. So the smallest figure I could have is 0.006. That's one motor, stepper motor, yeah? Step. So that's the smallest resolution. So then the second one is 0.0012. Hang on a minute. Hold on. One, three, four. That's what I had. Turns, 400 turns. Distance, it's set at 16 mil. Let me just double check that. Yep, 16 mil is enough. Small enough. Next. Now I'm going to run each layer. Okay. Or stop each layer. Normally, if you're going to put tape on each layer, have it stop. Now I'm going to do a full run. Carriage direction. It's from left to right. The arrows is forward, facing right. Winders forward. That's the winder, so it's going to turn this way. Full at margins. I'm not going to slow down at the margins. And back, so I'll exit. Okay. So now, by the way, the carriage, I can move the carriage, yeah? This is also slows down this carriage speed while I'm, so if I want it to go fast, I just turn that fast. I mean, to the high. And this also adjusts, when it's running, it adjusts the speed of the motor there. And also the carriage speed. So, let me adjust that. I think I need to bring that a bit closer there. Okay. Start about there. So I'm going to start slow on this one. And let's see it wind. Zero everything. And start. I'll speed it up, yeah. So. It's set for 400 turns. Coming. There you go. 400. Let's check the result. If it can focus, of course. Focus. Okay, cannot focus. So let's bring this closer. Where are we? and that's finished 400 turns. There. It's a pretty good wind. Okay. That's how that is. Okay. And we've done 3 layers, 400 turns by 0.134 millimeter cable. So it runs pretty good. Now the next improvement, if I really want to do that, I don't know if I'll ever do it, is at the moment this only have, at the back here, it has one sensor to pick up the turns. An improvement would be to put 2 sensors 180 degrees apart, and therefore I can move half a step in between half a turn. So the wire is already moving while turning, since this is not a stepper motor, okay? But it's still wind, you know, a 0.13 wire, pretty good. And I have one before, a smaller cable, and it's still wounded pretty good. Yeah. So that's just a paper former there. It's not a plastic one or anything. So yeah, that's the demonstration of the machine. Thank you.